Hey everyone, welcome back. I'm John with J4 Astro, and tonight we'll be diving into Orion to capture one of the most incredible sights in the autumn sky, the Horsehead and Flame Nebula. Stay tuned. What makes this target so special is that it's bright enough to capture from heavy city light pollution with just a DSLR or mirrorless camera, a telephoto lens, and a star tracker. Tonight I'll be walking you through every step, from finding the target, capturing the data, and processing the image. Stay tuned. There are many pieces of gear associated with the astrophotography process. In this section, I'll explain them. First is a bat-knob mask. Bat-knob masks allow you to easily achieve a sharp focus by creating diffraction spike patterns. Next is a t-shirt. T-shirts allow you to take a calibration frame called flat frames. I'll get into flat frames and the other two types of calibration frames in a later segment of the video. You also need to bring along your lens cap. Lens caps allow you to take dark and biased calibration frames. Now for the camera equipment. For my camera, I will be using the Sony a6400, which is a mirrorless camera. However, you can use whatever mirrorless or DSLR camera you may possess. For the lens, I will be using the Sigma 150 to 600mm lens, and I found that the 3 to 400mm range works perfect for framing up this target. You are going to want to use a star tracker or an equatorial mount. This will allow you to take long exposures of the stars without them trailing. Today I will be using the EQ6R Pro mount. You are also going to want a steady tripod, which will not shake in the wind. For camera settings, firstly ensure that you are shooting in RAW. After that, set your exposure to however long you can comfortably get without star trailing. On most DSLRs, there is a maximum exposure time of 30 seconds. However, this can be bypassed by using an intervalometer to set your exposure time. If you are using an intervalometer, set your camera to bulb mode, which will let the intervalometer control your exposures. Set your interval between shots to be around 10 seconds longer than your exposure time. This will allow time for your camera to write the data to your SD card. Next, make sure you set a static white balance. Turn off auto white balance and select either cloudy or daylight as your white balance. You're going to want to let as much light in as possible, which means lowering your f-stop to the lowest your camera can go. When it comes to using your star tracker, you're going to want to ensure that it is level. To do this, adjust the feet of your tripod until the bubble suspended within the green liquid on your tracker is in the center. Next, you're going to want a polar line. Ensure that your mount is pointed roughly north towards Polaris, and then set your latitude coordinates. You can look these up on Google by going to gps-coordinates.org. Enter your latitude by using the front and back adjustment bolts on your star tracker. After you've entered your latitude, which will angle your mount towards the North Star, use the left two bolts to sway your mount from side to side. Do so until Polaris is roughly centered within your finder scope. Now, go to an app such as PS Align, which will be linked in the description, to find Polaris's current angle. Match this angle with Polaris in your finder scope to have proper polar alignment. After you're finished polar alignment, you're going to want to place your camera on your tracker. Then you're going to want to balance it. To balance it, adjust the counterweights at the end of your tracker if you're using an EQ mount. You will know you are properly balanced once you can unlock your tracker and have your camera stay in its current position without swaying. In order to find these nebulae within the night sky, you can use the assistance of applications such as Stellarium. To find the object in Stellarium, you're going to want to first enter the object name. In this case, IC434. Click enter, and this will show you where in the sky the nebula is located. If you are not using an app, look for the Orion constellation. The constellation contains a string of 3 stars known as the belt. Underneath the leftmost star of Orion's belt, you will find the Horsehead and Flame nebula. Note that you may not see the nebula within your first exposure. However, if you have properly framed Alnitak, then you will see it after stacking. Now, it's time to shoot. If you are using an intervalometer and have already set your shooting settings, go ahead and press the start button. If you are not using an intervalometer and are using the interval shooting function, set the amount of exposures you want to take and how long you want between each exposure. Now that you have finished shooting, it is time to take calibration frames. First are dark frames. To take dark frames, leave all of your imaging settings exactly the same and apply your lens cap to your lens. Take around 30 to 50 dark frames, the maximized effect. Next are flat frames. Flat frames help remove vignetting as well as dust notes present within your imaging train. To take flat frames, you're going to need a t-shirt and a bright light source. Tonight I will be using an iPad, but you can use an LED screen, or if you're up late enough, you can use the morning sky. Secure the t-shirt to your camera lens using a rubber band. When it comes to settings, you're going to leave them the exact same as your imaging settings, except you will change your exposure length. Using your histogram, set your exposure length to have the histogram peak within the middle. Next are bias frames. These frames help calibrate your flat frames. To take these, place your lens cap back on your camera lens. Next, set your shutter speed to as fast as it can get. In my case, this is 1/4000th of a second. You're going to want to take around 50 of these. Thank you for tuning in for this exciting episode of J4 Astro. I hope you enjoyed or even learned something new. Make sure you leave a like, subscribe, and comment if you have any questions. Clear skies.